Hello and welcome to this video. I'm excited to walk you through how to create a cloud architecture diagrams using a simple online solution. To get started, my name is Afiz. I'm a certified TOGAF enterprise architect and a multi-cloud solutions architect, and I major specifically in Oracle and AWS solutions. I'll be showing you how to diagram your cloud architecture using an online solution. It's SaaS-based, which needs no subscription, no installation, no sign-on whatsoever. You just enter your simple URL and start diagramming your cloud architecture and many other things you want to create if you want to use the same solution. Uh, you know, Usually everybody uses Lucidchart, Microsoft Visio, and all, but they all need you to either have installations running on your system, or you need to sign on to a user account to get what you want. So I'll just be showing you a simpler way to doing this. I will just go through draw.io. I will wait for this to load. Draw.io is a simple diagramming solution that as I said, no sign-on needed, no installations, no subscriptions. Just go in there, create what you want to create. You can use all different kinds of services to create what you want to create. If you look at it, we have AWS. We can bring in Oracle, different formats and different services to diagram on this very solution. So we're going to create a three-tier web application using this tool, and it's going to be pretty simple. And you see how simple this goes. So let's talk about a three-tier web application hosted on AWS. What's this? What's it about? What's the setup all about? What's the purpose of such a setup? A three-tier web application helps you now hosting a scalable web application, maybe such as an e-commerce application, a CMS application, that requires a database backend and security at the backend, of course, through subnet isolation. So you're going to isolate your subnet, a private one, a public one, and for better security for your system. So one of the first things we're going to do is just to look at the top of this. We're going to search for shapes. So I do AWS, and you say AWS Cloud. Or that's all you need. You just press enter, and you get your cloud solution come up. It could be in different forms. You have more. You can let's go to more results and see different types. So I would rather choose something that has something like this. AWS Cloud. Okay, this is better. So I'll just go through this and make it as large as I can. I'll bring it up here and make this as quick as possible. So this is our AWS cloud. So in this cloud, we're going to be putting several things in there. One of the first things I would also like to do is, okay, let's create users and have users come out of this. So you have different kind of users. I'll just pick this user and make it outside our AWS cloud. We can expand the AWS cloud because we're going to be putting a couple of services in there to show the three-tier web application format. Okay, so we have our AWS cloud now. What else do we need? We need to create a VPC. So go to AWS VPC, and a VPC, that's your virtual private cloud, is to help you isolate your system to make sure this is just private to your organization or you alone. So I like the colored format, so I just use one of this, and I'll bring my VPC out here and just resize that to make it look. I just resize that to make it look as good as possible. I intentionally left the space here, and I'll tell you why I left the space. And let's just go on and continue building this. So this is our VPC. I'll just try to bolden the text so that it shows everything that is coming in here. So I'll bolden those information there. So what next do we need? We need a public subnet, you know. So AWS public subnet. Yeah, public subnet. Or we could even just say, we could even just, just put subnet there. It really doesn't matter. So I'm going to resize this as well so that we can place it right and give some space for the public, for the private subnet as well. So these are public subnet, and I'll just put it in the center here. Okay, let's create a private subnet next. So this helps to fulfill our isolation and helps with the security side of our architecture. So AWS private subnet, this is another one. So I will bring that out here because they shouldn't be together as well. So bring this out here and resize that as well. So you can see that all of this resizing and everything can do a lot in your architecture diagram using resizing and everything it has. So I'll just bold in this also and look for a way to come here and to move around all of that services or resources that we have in here. We can just use the tab. The tab helps you move around and you bold in that public subnet as well. What else do we need? So in our public subnet, we should have an application load balancer, which allows traffic to come in and be distributed around our resources. So I'm just going to do the same thing here and say application. Just type what you need. And each time you do that, it brings up just click enter and it brings up what you need. So this is an application load balancer. I'll resize this as well again. No, and just place it at the center of our public subnet. Let me give you some space so that I can place another resource here. I'll tell you what the essence of that resource is. So I can easily just label this by clicking on this and just write application. Just application load balancer. And I also bold in that as well. Okay, I can just copy this, just highlight it, sorry, then bold in it. We need an Amazon EC2 as a compute service. I will put that in our private subnets. So our EC2 is out here. We could use, let's use this one. So that goes into our private subnet. And we'll, of course, type in that AWS EC2. As well, I like this and bold in that. What other resource do you think we need? We need a service that we can use for our database where we store our data for structured data mostly. We understand different kinds of storage devices that we have, but in this situation, it's a back-end solution, so we need the database to store the data, structured data precisely. So we'll go back in there and type Amazon RDS. Let's use one of the simplest ones, Amazon RDS. And there's so many uses for Amazon RDS as well. So we use the RDS and we just pick this one. And we bring our RDS here. So this is almost a perfect diagram. Now, remember, we're not looking, it's not a complete diagram in terms of looking at cost and all those things and how best the diagram should be. It's just a simple diagram just to show us how to get this done. So for this to communicate, for our users to communicate with all of this, we need some services in between. We should have a Route 53 to allow your call-ups, your DNS, so that they can call up, so that they call up with the username, then it returns a DNS name for the service for you to communicate to the services inside this AWS cloud. So I will look for a Route 53 and make things easy. Let's just say Route 53, and we have one beautiful one here. And we'll just pick this one. Put it outside the VPC because that's how it communicates otherwise. So I put here again, I label it Amazon Route 53. I like that again and just bolded it. That's a good one. What else do we need? We need, how do we communicate with the resources inside the subnet? Ideally, for you to communicate with resources in a subnet, you need an internet gateway. An internet gateway is how the resources reach the internet and, of course, come back in. So here we look for an internet gateway. Internet gateway. Okay, internet gateway, we should just use this one. This should do. And we'll just place it right on top in our VPC. As I said, we bold in that also as well. Okay, that's solved the problem. Okay, our private subnet just don't work with the internet gateway for sure. So we need a NAT gateway, which is going to be placed in our public subnet for it to communicate with our resources in our private subnet. So here again, I come here and just reduce my typing and put in NAT gateway here. Okay, our NAT gateway this, we can use this as a NAT gateway, and we have this right in our public subnet. So there's some school of thought that would say, okay, the NAT gateway should be in the private subnet. No, actually, the correct way is to put your NAT gateway in your public subnet and have your users communicate through the AWS Route 53, goes through the application load balancer, which spreads it and gives a form of communication between your resources and the internet, right? Your internet cannot communicate to the resources, but resources can communicate. So it's a one-way egress um, mode of communication. So now we have all of this done. How do we now show the connections? How does this move? How do all of these things move together to show? Okay, we haven't actually labeled this one, and that should be a NAT, sorry, NAT gateway. Okay, we like that as well, and bold in it. That's good. So we need to find a way to use our connectors to communicate with all this. So we show, ideally there should be a green something ball that should come up when we just hover around these users, but sometimes it comes up, sometimes it doesn't. So you just pick a connection. So I pick this connector and I'll just drag it all the way to my Route 53. I can try to align this just so it's on a straight line. So from my Route 53, we look, this is the green stuff I was talking about. So it goes all the way to my application load balancer. I just align that so that it goes straight up. And from the application load balancer, I also am able to communicate with, we're able to communicate with my NAT gateway. And ideally, the NAT gateway, it should actually come this way because it's no more, it's not a matter of it's now it's egress, so it's just one way. So there should be a connector come from the other side, or we can actually just this is just to show, just for teaching purpose. So we can just put a connector to come here and just oh, that's wrong, and just come in and connect with the other one. Yeah, okay, this is good. And the database, of course, whatever things we need to, storage we need, goes into the database. Oh, we didn't label the database. Let's remember to do that. That's an Amazon RDS. Okay, I like that again. And we boarded it. So this is a 3-tier. Let's try to label this also. I'll just say users. And you can see how easy it is to put the text in there. And this just helps with the flow. And you've created an easy diagram of a 3-tier web application hosted on AWS. So we can of course just put a text here and just add I just add the and label this thing. Just say the tier web application hosted on AWS. I bolden this and enlarge it and make it very, very visible. So bolden, and I can resize it and just put it in the center, right? Could just use this one to centralize it, or use a different one to place it depending on how I want to do it. So this is a diagram for your, this is how to create your AWS cloud architecture diagram using draw.io, an easy solution online. I'm not saying this is the best diagram you can get because there's so many things we can actually look to making this function better. For me, I always use, let's just open a new page so that we can create something. For me, I always say that to have your AWS a perfect diagram or a perfect cloud architecture, we need to follow the 6 pillars of the well-architected framework. So what are the 6 pillars of the well-architected framework? Yes, we need to begin to just discuss them to show how they can help us shape a well-architected diagram. Okay, I just so I'll just quickly get to one of this and move this aside so it doesn't disturb what we're doing. So another text here is to, I'll say, how do we get started with a well-architected framework? Pretty easy. The first thing is our operational. The first thing we need to discuss is our operational excellence. Number two, we talk about security, and all of this is not big enough. Number three, we talk about reliability. Reliability. Number four, we talk about performance efficiency, and we'll discuss all of this. Number five, we talk of cost optimization. And number six, we talk of sustainability. And I'm sure we've all heard about the SDG goals and all of those things. This is part of what brings up all of those SDG goals and make us have a sustainable environment. Okay, so I'll take all of this and bring them down, and we just discuss them briefly and show how the well-architected framework helps us. Ooh, this is giving us some. Okay, let's just see. This is how the well-architected framework helps us build a proper cloud architecture. Operational excellence. Let's go back to our diagram here. So how do we improve it using the operational excellence? Of course, we use automations. We use automations to create some event bridge situations, or using AWS config to just configure our settings. Using automation, we can use Lambda to automate some processes instead of us going in there to manually create stuff, and use serverless technology. That's the Lambda side of things. The second one is talking about security. How do we enable security in the well-architected 6 pillars of well-architected framework? We use it to enable encryption, both at rest and in flight. In flight, we use HTTPS, and that's why we have it going through the Amazon Route 53. And at rest, we create server-side encryption or customized encryptions or key management service encryption. Either way, we want to do it. Looking at reliability, how do we make this very reliable? How do we make it very available for disaster recovery, fault tolerance, and all of those things? We use a multi-AZ. So ideally, in our VPC should have been created, we should have had another VPC created in another availability zone just to fail over to or for high availability. Then we can also have like a failover automation, based on the new AZ we've created, another VPC created in another AZ. And we can also have test recovery procedures, having for failure and fault tolerance. We have 4 types of ways of managing disaster recovery. Of course, we have the multi-site creation, which is expensive. We have Pilot Light, which is like the next least one. We have Backup and Restore, and of course we have the warm standby. So those are the 4 ways of having a proper um, reliability for our cloud architecture. And of course, it helps us to improve our RPO and our RTO, which is the recovery point objective and recovery time objective. Then we look at our performance efficiency in this architecture. So what could we have done better? We use serverless technology. We use auto scaling for AWS EC2. Sometimes it doesn't even matter if we don't use the auto scaling. We could just put a container here, where it is well managed for us. We don't need to do anything or provision anything by ourselves. So, but easiest and the cheapest, we just use an auto scaling group to the AWS EC2 where traffic can flow to. Should we have increased traffic, increased throughput, then it expands itself, and all those things. So that's for performance efficiency. And for cost optimization, of course, we can use our reserved instances for our EC2 rather than having, different kind of things. These reserved instances, we could do shut down and all unused EC2 services or resources that we have in there. We can monitor costs via different things. We can even create a budget to show that, okay, this shouldn't exceed this and all of those stuff. And the last one, of course, we talk about the sustainability. For our EC2, we could use Graviton, which is very much more environmental friendly and helps to reduce or manage workloads and, of course, to optimize usage. So this is in a nutshell is just to show you how to create uh, AWS cloud architectures using a very simple online solution where we don't need any sign on, we don't need any subscription, and we don't need to install anything. So in my subsequent videos after this one, we're showing you different ways of building a well-acted a diagram to show how best to enable cost savings, security, reliability, and all those other things in the 6 pillars. So thank you very much for staying with me on this, and hope to see you next time. Thank you.